Hello everyone and welcome to yet another math video. In this video, I intend to review linear function ideas. So in this first example on this page, you can see that we need to rewrite the linear function equation below this one in slope-intercept form, then graph the function. So the best way to do this, to get it into slope-intercept form, is to solve for y. So we're looking for a y equals here. And then we need to make sure that the other side of the equation is just simplified as possible. We don't leave any distributions or any terms uncombined. So that's what we'll do. So we'll start out with the 5x plus 2y equaling 10, and then subtract 5x from both sides. Sorry, it's negative 10. So you get a 2y equals negative 5x minus 10. Then to solve for y, you can divide everything by 2. And that'll leave you with a y equals negative 5 over 2x minus 5. In order to properly graph this, we will need to identify the slope, which is the number multiplied to the x, and the y-intercept, which is the number either being added or subtracted to the x term. So graphing over here, we can find the y-intercept on the y-axis. It looks like it'd be right there. Then we can use the slope to move around. Since it's negative, the slope will go down left to right. So that's how I'm going to start. I'm going to go down 5 and then right 2. And I'll place my next dot. And then I can travel exactly backward. If I go up 5, left 2, that will give me another dot, and so on. And so on. And then I can connect these and have my line. Don't forget the arrows at the end of your line, and you'll be good to go. Next. Find the slope and y-intercept of the line 3x minus 4y equals 24. Now, just in that last example, I mentioned if you are trying to find the slope and intercept, then you should put this in slope-intercept form, which is y equals mx plus b. So in order to do that, I'm going to start out with the equation 3x minus 4y equaling 24. And I'm going to follow the same solving technique from the very last example. I'll move the x term to the other side of the equation by using the opposite operation, either addition or subtraction. So here we go, minus 3x plus 24, and then divide by negative 4 to solve for y. And I get y equals 3/4 x minus 6. Be careful with your signs there. And you can see again the number multiplied to x is the slope, and the number being added or subtracted to the x term is the y-intercept. On this slide, we will write the equation of the line that goes through the points in point slope and slope-intercept forms. Point slope form, I say you should just generally do that first because the equation is a whole lot easier to create out the gate than the slope-intercept form. So in order to understand that, you need to know that the point slope form is y minus y1 equals m times x minus x1. Importantly, I want to point out that both the point slope and the slope-intercept form both require you know the slope. And in both of these scenarios, you don't know the slope. So we need to find the slope first, which is m equals y2 minus y1 all over x2 minus x1. And I think I'm going to just do part B and then let y'all try part A on your own. So what that means is I can call this point number 1, I can call this point number 2. We have an x and a y, we have an x and a y. So now I know what y2, y1, x2, x1 are. And I can just substitute numbers in over here. Y2 is 7 minus y1 is negative 4. X2 is negative 4, and Y2 is 7. All right, so it looks like the top will be 11 and the bottom will be negative 11, so this should be negative 1 for the slope. And this is a really nice slope to have because we can just substitute negative 1 in here for the slope, the m value, and then we get x minus, we can take either of these points and use it in the point slope formula. I think I'll just stick with x1, y1 because that's what I see here. So you can take the opposite of this value, the x value, and just plug it right into the equation. So x minus 7. And we can do the same thing for the y value. Take the opposite of that, plug it right into the equation, plus 4. So this is the point slope form. And then to solve for the slope intercept form, all you need to do is solve for y, and then make sure there's nothing to simplify on the other side, just like in the previous couple examples. So the first thing I plan to do is distribute this negative 1. That will be y plus 4 equals negative x plus 7. And then I can subtract 4 from both sides to solve for y to get y equals negative x, what is that, plus 3. And that is the slope intercept form. Oops. On this slide, we will graph and label the following linear equations on the same coordinate plane provided. Now, this is a word I use, label. This is just so I can check to see if my students know which line is which. In order to be successful with this, it's essentially axis equals some number, if you want to think of it like this. And what do I mean by that? I mean, on the x-axis, we need to find negative 3. So just for part A here, on the x-axis, I need to find negative 3 like this. And then it's remembering that x lines are vertical and y lines are horizontal. So since this is an x line, it will be vertical. And to show you really quickly the y line, y equals negative 6. That means we find that number negative 6 on the y-axis, like this down here, and y lines are horizontal. Now, this graph is not enough for the students I teach or what I expect of my students. I really want to make sure they know which line is which, and I'm using different colors so you can see it, but labeling them looks like this. X equals negative 3, y equals negative 6. Just put the equation, or let the line point with one of its arrows to the equation of the line it represents. And that is how I can tell my students understand which is which. Go ahead and take a moment and see if you can graph this one on your own. I'll come back in a few seconds with a solution. No spoiler, here it is. All right, that's the answer for that one, and that concludes the video on linear function equations review. See you in the next one.